In order to find the area of a composite figure, we first have to understand what is a composite figure. A composite figure is a 2D figure, which means it's a flat shape that is made up of two or more geometric shapes, like triangles, rectangles, or trapezoids. So it is a larger shape that is composed of lots of different shapes. So let's look at one here. So this pink one down at the bottom is a composite figure. It's not just a triangle or a rectangle or trapezoid, or we could also be like circles or squares and things like that. It is those shapes put together. And here is another one down in the right-hand corner. So today what we're going to do is we're going to find the area of these composite figures. In order to find the area, we got to know our formulas. So if you don't have your formulas, go ahead and pause that video and write those formulas down. So let's get started. Here's that pink composite figure again. So we're going to go ahead and find the area of this shape. In order to do that, we have to make a plan. So I want you to kind of look at this shape and decide what shapes do you see inside there. Okay, so you may have said you saw some triangles, maybe some rectangles, maybe you even saw a trapezoid. Now your goal is to break the shape up into the shapes that you see. Everybody's going to see it a little differently. What I saw was a triangle and a trapezoid. So I have a triangle over here on the left side, was on my first shape. And then over here I have a trapezoid that's been turned on its side. So make a plan. Figure out what shapes do you see inside the composite figure. And then go ahead and write them down. Since we are finding the area of both these shapes, to get the total area, we are going to add the areas together because we are combining the area of those shapes. So I'm going to find the area of this triangle and the area of this trapezoid and add those two areas together to get my full area of this entire figure that I see here. So now I need to go ahead and identify my measurements. So since there's no measurements given, I'm going to use my graph paper here. So I'm going to go ahead and start at the base of my triangle and count the number of units I see. So 1, 2, 3, 4. The base is 4 units. Now when I find the height, I need to make sure I have a right angle. So the right angle is in this corner down here. And so I'm going to go ahead and start at the right angle and count to the top of the triangle. 1, 2, 3, 4. So my height of my triangle is 4. When I get to the measurements of my trapezoid, I mean my two bases and my height. So I already have one base that is identified. And then look for that right angle for the height. So I'm going to count 1, 2. So the height of that trapezoid is 2. The other base is across the from the other base because they're parallel. 1, 2 units. Now that I've identified my measurements, I can go ahead and write my formulas. I need my triangle formula and my trapezoid formula. And then step 4 is just to solve the problem. I'm going to find the area of the triangle and the area of the trapezoid and add it together. So start with one shape at a time. Don't try to do both at the same time. You're going to get a little lost. So triangle area is 1/2 base times height. So I'm going to go ahead and fill in my formula. My base and height were equivalent, so 4 times 4. And technically, it does not matter the order that you multiply these in because of the commutative property. However, I like to just go back to how the formula is derived. And so I'm going to go base times height and then times 1/2. So 4 times 4 is 16. And 16 times 1/2 is the same thing as taking 16 and dividing it by 2. So 16 divided by 2 is 8 units. Now, don't forget its area, so it's units squared. Now let's work with the trapezoid. The trapezoid formula is here. I'm going to go ahead and fill it in. Remember, my bases are parallel to each other and my height is the right angle. Now, it does not matter which one you choose as base 1 and base 2 because it does not matter the order you add numbers in. That is also the commutative property. Now we're going to follow order of operations. Parentheses first. 4 plus 2 is 6. When I get here, it technically doesn't matter the order I multiply, but I'll go back to how the formula is derived. It's the sum of the bases times the height and then times 1/2. So 6 times 2 is 12 times 1/2, which is the same as dividing by 2, is 6. Don't forget units squared. Now go back to our plan. We were going to find our triangle area and our trapezoid area and add them together because I want the entire area of this figure. So I'm going to go ahead now and add those two together, and 8 plus 6 is 14 units squared. Let's take a look at another example, not on graph paper. So I'll give you a second to look at the shape and decide what figures do you see. Now be sure when you split the shape that you split the shape using right angles. So what I see here is a rectangle and a triangle. The rectangle measurements are given. So I'm going to go ahead and identify the triangle measurements. Well, since this is a rectangle, the parallel sides are equivalent to each other. So this side right here, which is actually the base of the triangle, is 6 meters. Now, to get the height of the triangle, remember that it needs to be a right angle. So the right angle would form right here at the base to the top. So what I need to see here is that the distance all the way across this shape is 10, but the length of this rectangle is 7. So if I continue across to the top of the triangle, it will be the difference between 10 and 7. So 10 minus 7 is 3. So the height of the triangle is 3 meters. Now let's go ahead and write our formulas. We need our rectangle formula and our triangle formula. Now we can solve. So the area of a rectangle is base times height. The base is 7, the height is 6. 7 times 6 is 42 meters squared. Now let's do our triangle. The base of the triangle is 6, and the height of the triangle is 3. 6 times 3 is 18. Half of 18 is 9. Now, go back to our plan. We're finding the area of the rectangle and combining it, which is adding to the area of the triangle. So take our two measurements and add them together. 42 and 9 together make 51. So the area of this composite figure is 51 meters squared. Here are some takeaways. Be sure to split the shape with right angles. Make a plan on how you're going to solve. You may need to find the length of some of the missing sides. Add the areas of all the shapes together at the end. Go ahead and practice this one right here. Pause the video to practice. All right, I'm going to go ahead and reveal the answer for you so you can check through your work.